Good morning everyone. Welcome back to Grade 5 Mathematics class. How are you all doing today? So we have started the new chapter Patterns and Symmetry. Today let's talk about patterns. In the previous class we have seen that when something is happening repeatedly or regularly, we say we have a pattern, and we have seen patterns with designs. When we have a pattern with designs, the designs repeat. You can see examples here. You can see the designs are repeating to create a pattern with designs. But when we talk about number patterns, it need not that the numbers repeat like in the case of patterns with designs. When we talk about number patterns, we usually mean a sequence or series of numbers is generated based on a logic or based on a rule. Here you can see a couple of examples. You can see a number pattern here. The first one, 1, 2, 4, 8, 16, etc. How the next number is generated in each case? The first number 1. The second number is the double of the first number. The double of 1 is 2. Double means you are multiplying it by 2. Then after 2, it is doubled to get 4. Then 4 is doubled to get 8. 8 is doubled to get 16. 16 is doubled to get 32. And what could be the next number? It should be the double of 32. And what is it? Double of 32 or 32 into 2 is equal to 64. Clear? So this is the logic or the rule for this number sequence or number pattern. And what about the next example? You have 1, 3, 7, 15, 31, and it goes on like that. Look at the first number, 1. The second number is 3. How would you get 3 when you start with 1? Is there any kind of relationship or is there any kind of logic behind this? There may be different logics to the same sequence. Say for example, in this case, the first number is 1, the second number is 3. And what is 1 into 2? 1 into 2 is 2, or the first two counting numbers, the product of the first two counting numbers. 1 into 2, 2. Plus 1 is equal to this 3 here. Then that 3 into 2. Just like we multiplied 1 by 2, we are multiplying this 3 by 2. 3 into 2 is equal to 6, plus 1 will give you this 7. So we can say for this number sequence, it has a logic of this 1 into 2 plus 1 gives you 3. In the second case, it is 3 into 2 plus 1. And what about this 15 here? 15 is 7 into 2, 14 plus 1 gives you 15. And 31, 15 into 2 equal to 30. That 30 plus 1 gives you 31. So here the logic is like the previous number multiplied by 2 plus 1 gives you the next number. So what should be the next number after 31? It would be 31 into 2 plus 1. What is 31 into 2? It is 62. 62 plus 1 is 63. So after 31, it should be 63. Hope this is clear to you now. Now, let's talk about square numbers. You see some dots are arranged here to form squares. In the first case, just one dot is there. In the second case, 4 dots are arranged in the shape of a perfect square. In the third case, 9 dots are arranged in the shape of a perfect square. Then 16 dots form a perfect square. So look at these numbers. We have a sequence. We have the sequence 1, 4, 9, 16. And it may go on like that. Look at these numbers. Do you notice anything special about these numbers? The first number, 1. This 1 can be obtained by multiplying this 1 to itself. 1 into 1, which gives you 1. The second number is 4, which you can get by multiplying 2 by 2 itself, the number by number itself. 2 into 2 is equal to 4. The third number 9. 9 can be obtained by multiplying 3 to 3 itself. 3 into 3 is equal to 9. Hence, the fourth number 16. 16 is equal to 4 into 4. So, such numbers that can be obtained by multiplying a number to itself are called square numbers. And these numbers can be represented using dots which can be arranged in the form of a perfect square. So, numbers such as these are called square numbers. So, when you say the square of a number, it means that you are multiplying that number to itself. For example, if you say the square of 5, the square of 5 is 5 into 5, which is equal to 25. The square of 8. Square of 8 is equal to 8 into 8, which is equal to 64. So, that's about square numbers. Now, we'll see what are triangular numbers. Here, you can see some numbers arranged in a sequence. 1, 3, 6, 10, 15. The first number is 1. The second number is 3. If you look at the counting numbers 1, 2, 3, the sum of the first two counting numbers 1 plus 2, that is equal to 3. So, here the second number is 3, which is the sum of the first two counting numbers, which is 1 plus 2 gives you 3. Now, look at the third number 6. 6 can be obtained by adding the first three counting numbers. 6 is the third number here, so you add the first three counting numbers 1 plus 2 plus 3. 1 plus 2 plus 3 is equal to 6. The fourth number is 10. So, from the examples of the previous numbers, 10 should be the sum of the first four counting numbers. Let's check. 1 plus 2 plus 3 plus 4. 1 plus 2 is 3. 3 plus 3 is equal to 6. 6 plus 4 is equal to 10. So, yes, the fourth number 10 is the sum of the first four counting numbers. Now, the fifth number 15. So, it should be the sum of the first five counting numbers 1 plus 2 plus 3 plus 4 plus 5. And yes, this sum is equal to 15. So, such numbers are called triangular numbers. Such numbers can be represented using dots, and these dots can be arranged in a triangular form. So, what would be the 15th triangular number? The 15th triangular number would be the sum of the first 15 counting numbers. What would be the 21st triangular number? It would be the sum of the first 21 counting numbers. So, I hope this is clear to you now. Now, let's see some patterns in a calendar. I'm sure all of you have used a calendar. You can see a calendar here. Now, take any square 3 by 3 block of dates. What do you mean by a 3 by 3 block or 3 by 3 square? It means there are 3 rows and 3 columns. So, I'm going to consider this block. So, if you consider this block, do you see any pattern or is there any relationship between the numbers? You see, here you can see the 3 by 3 square block. Look at the numbers. You have 2, 3, 4 here, 9, 10, 11 here, 16, 17, 18 here. In the middle, you have the number 10. See, if you take the sum of these two numbers, this 2 and 18, you'll get a sum of 20. And 20 is the double of 10 here, which is the number in the middle. And what about the sum of other numbers? The sum of these opposite numbers, 9 and 11, that is also 20. The sum of these two numbers, which are opposite numbers, 16 plus 4, that is also 20. Then 3 and 17, that is also 20. So, when you add the opposite numbers, you get a sum which is double the number in the middle. Clear? Let's consider another 3 by 3 block from the same calendar. Let's consider this block where you have 6, 7, 8, 13, 14, 15, 20, 21, 22. The number in the middle is 14. Let's take the sum of the opposite numbers. 6 plus 22. 6 plus 22 is equal to 28. And 28 is the double of 14. Now 7 plus 21. 28. Again the double of the number in the middle. 14. 13 plus 15. 28. Again the double of the number in the middle, which is 14. 20 plus 8, 28. So you see there is a pattern. When you consider a 3 by 3 block or 3 by 3 square from a calendar, the sum of the opposite numbers would be the double of the number in the middle. So there we have a pattern. Now let's see a different pattern using this calendar. I'm going to consider the numbers in this column. Let this be column 1 and the next column, let it be column 2 and the next column, let it be column 3. Take any two numbers from column 1 and column 2. Let it be 1 and 2. What is 1 plus 2? 1 plus 2 is 3, which is a number in column 3. Let's take two different numbers, 15 and 9. What is 15 plus 9? It is 24. And you can find 24 in column 3. So there we have a pattern. Take any two numbers from column 1 and column 2, add them together and the sum, if the sum is less than 31, the sum would be a number in column 3. So there is another pattern that we get using calendars. You can find different types of patterns in a calendar. You can try finding patterns yourself. Now children, you can go through the topic patterns in page number 115 to 117 of your textbook. And as a homework, you have to do the try this column, which is in page number 115, that you can see 4 number patterns or number sequences which you can complete easily. You observe the numbers carefully, try to find out what is the logic for that particular sequence and then complete the sequence. Now, in page number 117, you can see the exercise 7.1. You have to complete that exercise as well in your notebook. Once you're done with the activities, you can take a picture and send us through Teams. So that's all for today, children. We will meet in the next class with a new topic. Till then, bye.